Hey, welcome everyone. I wanted to record a short video that clarifies how to calculate percent concentration and actually how scientists do this in the lab when they're making solutions. So I'm going to just share a screen here and go through an example problem like the type that we're going to use in class and that you might see on a test and in the example. So I want to clarify two separate ways. I'm going to first show the way that I want us to do it because it's the way that works in the science. So let's say I have a question that says, what is the percent concentration? So what is percent concentration of 5 grams of salt, NaCl, that's salt, sodium chloride, table salt, in a total of 100, let's change this really quick. Let's make it 125 milliliters of water, okay? So when I say this in a total, another way to say it in the lab is in a total of, and we say, what is the concentration of 5 grams of NaCl when it's the solution is brought up to 125 mLs. So to answer this, the first thing you need to know is that 1 milliliter of H2O of water is equal to 1 gram of water. So I use this example in class that this is 700, this bottle, I got this free at Quick Trip. This 700 milliliter bottle has 700 milliliters of water in it. It weighs 700 grams. The water in it weighs 700 grams. Of course, the plastic might weigh a little something. So we're going to use that in our calculation. Now, what I'd like to do is show you practically how we do this so that you can use that to visualize. So we'll go on a little field trip here, and I'm going to show you in a lab how I would do this. So I need to make, so my recipe, right, in the lab, sometimes we make solutions. It's either to grow cells or to digest some plant material so I can get the DNA out of it. We make these different solutions and there's recipes for them. And one recipe might say, I need a 5 grams of salt brought up to 125 mLs, or 5 grams of salt in a total of 125 mLs of water. So the question then is, how do we do that? So if you can see my balance here, maybe I can adjust this a little bit. You can see my balance right here. So, and I have a graduated cylinder. This is a big one, but right here is 125 mLs. So what I do is I take a little bit of weigh paper, place it on my balance, and I zero it out or tare it, T-A-R-E. And now I take my salt and I knock out getting there. I get exactly, let's see if I can get exact here for you. I try to get exactly, and this is how I do it in the lab. I just tap it out. And I don't like, when I work in the lab, I don't like to stick spatulas into my actual reagent. So I just kind of knock it out. And there we go. So you'll see, you can see that I got 5 grams of salt. So then I take my empty graduated cylinder and I take the salt and I pour it into the graduated cylinder. So now I have my 5 grams of salt in there. And that actually takes up a little bit of space, which will become important when I do the next step right here, which is to fill this up. So we get the water going. Get a little off the side. Whoop. And I'm at 100, 120. Probably turn this down just a little bit. And I got, nailed it. Exactly 125. So now this is 5 grams of salt brought up to 125 milliliters water. So if you think about this, that 5 grams of salt actually takes up a little bit of space. So I probably don't have 125 milliliters of water. It didn't take that much. And now that 5 grams wasn't a lot, but if I had put 15 or 30 in here, now that's going to take up a considerable amount. So then what I would do if I were in the lab, I'd have my gloves on, but this is just salt. I just kind of mix this up a little bit, right? And now I have a dissolved 5 grams of water brought up to, or like I say on the test, in a total of 125 mLs of water. So let's go back and now make that calculation. And so that is the most typical way that it's done in labs, is you bring it up to. Usually in a lab recipe, actually, they will tell you the percent concentration, and you have to do all your own calculations for yourself unless you've made the recipe. Okay, so let's go back to our practice problem that we were working on. And I'll share in just a second here. All right, back out of here. Okay, so our 5 grams of sodium in a total of 125 mLs of water. And maybe that's not the best way. Maybe I'll change the wording. So 5 grams of NaCl brought up to 125 mLs of solution. Okay, so what I want you to do for this class is then the percent concentration equals the 5 grams of sodium chloride divided by, now we had 125 mLs of solution, and there was a little bit of salt mixed in there, but that salt mixed into the water doesn't change the mass enough. It does a little bit, but doesn't change it enough for our purposes. So this is now 125 grams of solution. And then we multiply that by 100%. And we get 5, I'll do that on my calculator. 5 divided by 125 equals 0.04. And now I need to multiply that by 100%. So the total is, this is a 4% solution. That's the way that I want us to do this in class. Now think about how this might be different for what you did. When you were measuring yours, let's say I took 1 cup of water, which is equal to, I think that's equal to 237 milliliters. And then I poured out a cup, and then I added in 2 tablespoons of NaCl. And each tablespoon apparently weighs 17 grams. So that would have been 34 grams of salt. Now, if I wanted to calculate this percent concentration, remember, I didn't bring the volume up. I already had a cup, and then I added more salt to it, which would raise the volume a little bit. So in this case, what I did is if I had, let's say I had a beaker here, and I had a measuring, this is my measuring cup. And I measured my measuring cup, right? And I then took this and dumped it in here. That's 237 mLs. And there's the water level once I've dumped that in, right? And now if I take, I'm gonna make a little spoon of salt. And now if I add that in once, that's 17 grams, and then add it in again, 17 grams, my level of water is going to rise a little bit, right? Because that salt is going to take up some space. So the total mass of this solution is a little bit more now. So in this case, my percent concentration is equal to my 2 tablespoons, 34 grams of salt, 34 grams, divided by the total mass of this new raised up solution. And that total mass is the original 237 grams from the cup of water, right? That comes from this cup of water, plus the 34 grams from the salt times 100%. So this is not how I would do this in the lab, but it's how we do it in the kitchen, right? So if I did this, this changes a little bit. So this is now 34 grams, all cancel out, divided by 271 times 100%. So this is now 34 divided by 271 is 12.5 times 100, or sorry, it's 0.125 times 100. And now this is approximately 12.5%. Okay, this is how we did it. This is how we did it in the kitchen, in our, right? This right here, this is science lab. This is how we do it in the science lab. Okay, so for the practice problems and the test problems, I want you to do it this way. So let's say we had 19 grams of sodium chloride in a total of 225 milliliters of H2O. Okay. And we want to know the percent concentration of that. Percent concentration. This is equal to our 19 grams of salt divided by our 225 milliliters, but 1 milliliter of water is 1 gram of water, grams of H2O, grams and grams cancel out, times 100%. This would be equal to 19 divided by 225 is 0.084 times 100. This is approximately an 8% solution. Okay, so that's how I want us to do percent concentration for the test and for knowing about this for science. All right, I hope that helps clarify things. As always, let me know if you have any questions, and we'll see you next time.